All right, so what we're going to be doing here is we're going to be talking about comparing two proportions. Now, last class we were going into using a confidence interval to compare two proportions. However, today we're going to be doing this using a hypothesis test. I'm going to be breaking down this video into two parts. The first part is going to be general notes and an overview of everything that you need to know in order to be able to do this. Now, the second portion might even be even more helpful because the second portion will involve tons of practice problems. I would highly recommend that you work through these problems as they are exactly like your homework problems and may have something to do with what we will be doing in class next time. So the first thing that we did last class is we were dealing with two proportion z intervals. And we said that this was an extremely useful tool because a lot of times we don't want to just answer a question about one population, but we wanted to compare two populations. But in order to do that, we first had to make sure that the conditions were met in order to continue. Then we had this formula for a confidence interval being very similar to the formula of a single proportion confidence interval, only this time we're using p hat 1 minus p hat 2. And instead of using standard error of one proportion, it's a standard error of the difference. And we had a new formula for that, where the standard error of the difference was the square root of the standard deviation of the first population, standard deviation involving the second population. Z star was still exactly what it's been before, and that dealt with our confidence interval. And you might want to recall that the method that we used to find these, to find your Z star in your calculator, you did inverse norm, and then you always did 0.5 plus whatever your confidence level was as a decimal over 2, and then using our standard normal distribution, so our mean was 0 and our z-score was, our standard deviation was 1. And this allowed us to find z star, no matter what our confidence level itself was. So, just a little bit of review. Those assumptions and conditions were virtually the same as what they had been before. We still had that we needed randomly drawn or randomly generated subjects. We needed 10%, which means that within each population, we could not exceed 10%. But we added this new guy, independent groups assumptions. And that was that the groups had to be independent of each other. So that was our one main difference. But then we also had to check that each of the groups were going to be big enough in their respective populations, both bigger than 10 successes and 10 failures. Okay. When we're talking about a hypothesis test, things do change. Remember, a confidence interval is how confident are we in our actual sample. And so we start with our sample and we do all of our computations from there. A hypothesis test is exactly the opposite. We want to know, is our believed values still true? So we start with the population proportion, or what was or what we believe is the population proportion. And then we go from there. And then we see, does our sample uphold what we previously thought was true? Now, when we're doing a hypothesis test comparing two proportions, really, there is no difference in how we do this. But the problem is instead of talking about one proportion, we look at the difference. Now here you can see that this is written as your null hypothesis is that P1 minus P2 is equal to 0. That means that we believe that there is no difference. Sometimes you will see that written as P1 equals P2. Notice that's the exact same thing as if I'd wanted to get them both on the same side of the equation. Okay? Since the null hypothesis is that there are no differences between the populations, our standard deviation deals with that as well. Recall before what we were talking about for our standard deviation, we used that in a hypothesis test, a standard error, and a confidence interval. We always used the proportion that was available from our null hypothesis. Our null hypothesis here contains no numbers other than 0, and we can't calculate a standard deviation off of that. So we have to go a different route. And basically what that is we are going to take our sample and we are going to pool them together to get one overall population. We're going to assume that they came from similar populations where there is no difference. Now, if you want to think about it like you are going in for pizza and everybody pools together their money to buy a pizza, that's just basically where everything goes into the same pot and you deal with the total from there. The thing here is we only ever pool in a hypothesis test. That cannot be stressed more. You're going to have a lot of different formulas that you have to deal with here. And the one thing that you need to understand is the only time you will ever pool your standard error is in a hypothesis test. So the way we actually find our hypothesis test, we use p pooled. Notice that that's written as p hat pooled because that's taking our observed sample and pooling it together. All of the successes from the first group and all of the successes from the second group, totaled together, summed up, divided by the total number in both groups. So that's all successes over all attempts. And the first thing you ever want to do is you want to calculate that proportion. Remembering that the chance for one particular success is the size of that sample times the probability of that success. So if they don't give that to you, you are going to need to be able to compute that. Remember, we talked about using our calculators to do this. Well, in order to use our calculators, we're going to have to be able to talk about the total number of successes in each group. Now, this is the only time you should ever round values in a computation, and that is when the number of successes themselves are not whole numbers. It is only in a hypothesis test of two proportions, and that's just because you can't physically calculate them using decimals. We together put this pooled value into your formula, and then you use that to find the standard error. So our formula for the standard error of our pooled difference in samples, we take that pooled value, whatever that is, that guy is our pooled, Q hat is the opposite of that. So if these are my total successes, either 1 minus that is my total failures, or we can take a look at the difference between the top and the denominator. And then we times that by 1 over our first sample size plus 1 over our second sample size. This is an extremely important formula putting together these two ideas. You must memorize these. Once we have that, we can go ahead and actually start doing a two-proportion z-test. Now remember, in every single test, we have to have some sort of statement. If the conditions are met, we have to say a two-proportion z-test is what we're going to be doing. You state your hypotheses. Remember, you have a choice between a null hypothesis written like this or written like that. They're the exact same thing. We're just basically saying, how do you want to write it? I prefer going that way simply because we're going to be interested in what that number is right there, and we can see it written in this form, but not written in the other way. To find your test statistic, you're going to say your z, because remember, it's not z star, this is z itself, is p hat 1 minus p hat 2. These are your observed statistics minus the null hypothesis. And that 0 just comes from the fact that the null hypothesis says that that difference is actually 0. And then we divide it by the standard error pooled of the differences. Remember, using that formula that we just saw. When the conditions are met, and your null hypothesis is true, the statistic should follow the standard normal model. So you want to make sure that with the sampling distribution, that you include talking about that it follows the normal model. And then we just go about all of our previous methods to find the p-value. So what you can do now is I'd recommend that you go and you actually look through some problems. We're going to be doing practice quiz 1A at the start of class tomorrow, but you'll see completed examples